Welcome or welcome back on C Square. In this lesson we will talk about central angle and the arcs that go with central angles. And first of all, let's see what a central angle is. Is this angle, you see it here in this picture, it's an angle that has the vertex right here where the center of the circle is. Okay, this is the angle is called ATB or TBA, either way is good. An arc, it's a part of the circle, and there are two types of arcs, a minor arc and major arcs. A minor arc is less than 180 and a major arc is greater than 180. You see that in this picture. So arc AB, this arc, is the minor arc. ACB, you notice we use three letters, is the major arc. And if you notice, the sum of these two arcs is nothing else than 360 degrees, which is the measure of if you rotate around like that. So now we have a special type of arc, the semicircle, which is half of the circle. And you notice here we have two of them, obviously, because you cut the circle in half. So the measure of arc ACB, that's the meaning of this M here, is 180 degrees, and the measure of arc ADB, it's also 180. The measure of a minor arc is equal to the measure of its corresponding central angle. That is another thing that you want to remember. So for example, if the measure of the angle is 60, the measure of the arc is 60. And vice versa, it works the other way also. If the measure of the arc it's, let's say, 60, the measure of the central angle is 60. Now you notice the major arc will be 360 minus this 60, and that will be 300. You may see a picture like this where you notice congruent angles. If the central angles are congruent, guess what? These corresponding arcs are congruent. That's what it says right here. And this is the converse. If the arcs are congruent, the angles are congruent. And you see the theorem also here. Adjacent arc, like in this case we have two adjacent arcs, arc AB and arc BC. If we add these two arcs, we get arc AC. And now let's see this example. And in part A, we need to find the value of x, in fact, in all of them. So here, I'm going to write this equation, x plus 110 plus 57 plus 98 equal 360 degrees. You go around that center of the circle, you get 360 degrees. So now let's combine the three numbers. So we have 110, 57 and 98. If we add these three, we get 265 equals 360. And obviously the last step will be to subtract 265 and that should be 95. That is how much x is 95 degrees. Let's take a look to part B. Very similar. We're going to write an equation, x plus 112, and whenever you see a box like this, that will be 90 degrees equals 360. So 112 plus 90 degrees is 202 equals 360. Subtract 202 now, very similar to what we did in the previous part A, and we have an x of 158 degrees. And let's take a look to the last part. Last part we have a semicircle, right? So this arc here is 180 degrees. In fact, this angle is a straight angle also. So either way, we can write x plus 123, if we look to the angles, equals 180. Of course, you can use the same equation and write for the corresponding arcs. Subtract 123. And we have here 180 minus 123. That will be 57 degrees. And that is about this example. In my next example, we're going to look to a very similar part, a very similar problem in fact, but now we need to look also to identify if we have a minor arc, major arc, or semicircle. So let's take a look to the measure of arc AB, the first one, and we notice this arc AB is this guy. So for that reason, we need to know this angle. The question is, how much is that angle? And if you take a look here, we know AD is a diameter, so this whole angle will be 180 degrees. So it makes sense to write this statement first. I'm going to put it here. 40 plus 120 plus the measure of angle ATB or BTA equals 180. Okay, so yeah, if we add these three angles, we should get 180. So we have here 160 plus the measure of angle ATB equals 180. So obviously the measure of angle ATB will be 20 degrees. So if this angle is 20 degrees, the arc will be 20 degrees. Remember, the central angle and the measure of the corresponding arc are the same. So let's move to the next part. We need to find the measure of arc DC. DC is this arc here, and if you notice, it goes with this angle, angle CTD, and that angle has a measure of 20 degrees, right? 20 degrees here. Why? These two angles are congruent. They are vertical angles in case you need to justify your answer. So this one will be also 20 degrees. Now we can move to the next part, the measure of arc AC, which is, let me use this green now, this arc. And by the way, let me also label major, minor, and semicircle. By the way, this is a minor arc. Okay, but how much is that arc? So for that reason, you should be able to find the measure of this angle. And if you notice, that angle should be equal to this angle. They are also vertical angles. And that angle I mark is 160 degrees, 120 plus 40. So the measure of angle CTA is 120 plus 40, and that will be 160. Okay, so this arc is 160 degree. And we have a last part. We need to find the measure of arc ECA. ECA. So let me erase a little bit of picture. So to see what that angle is. And that ECA, you start from point E, go through C. Okay. And this is the arc ECA, the red arc you see here. And you have choices here. Remember that this angle here is 160. We did it the previous step, so we can do 160, that angle, plus this angle, so 160 plus 20, plus this 40, plus the 120. Oh, no, we don't need a 120, sorry. Just these three, right? So these three angles are the angles that, if we add them together, they give us the central angles, this big one, right? So that will be 180, 220. That means this guy here is 220 degrees. And now let's be sure we label the things. This is a minor arc. This one, the second one, is a minor also. This is a major arc, and usually when you have a major arc we use 3 letters. And the part C is another minor arc. In the next part we move to the arc length, and you notice here I said that while the measure of our arc is in degrees, the measure of the arc length is in fact centimeter, inches. It's a different unit. You have two formula here, and you see them right here, two ways in fact. This one use proportion, where I said the length of arc AB, this one, is a part of the whole circle. For that reason I wrote this proportion, the length of arc AB over 2 pi r, which is the circumference. Okay, remember this is the circumference of the circle, equals x, which is how much this angle is, over 360, the whole circle. If you solve for the length of arc AB, you get this formula. If you remember, that's good. Usually what I do, I write proportion, and proportion can be written in different ways. So I'm gonna show you probably more than one way. So let's take a look to this example. In this example, we need to find the length of arc AB. Do you notice the central arc is 60 and the radius is 8 centimeters. The first step you want to do is find the circumference, 2 pi r, and that will be 2 times pi times 8, and that will be 16 pi. We're going to keep the answer in pi. In fact, you notice that in terms of pi. And now we're going to look to the length of arc AB, and I'm going to show you proportion. So length of arc AB, that's what I said here, over 2 pi r, the circumference, 16 pi, equals, so now on the other side you need to be consistent. Here the length of arc AB will go with the measure of the corresponding central angle, which is 60 degrees over 360. Okay, you may want to put the degree also, just to be sure you are consistent. We don't really need the degree, so we can erase it. And now it's like any other proportion, you cross multiply. Okay, so let me rewrite that as x over 16 pi. I think it makes more sense. 60 over 360, which can be simplified also if you need, but let's say we're gonna cross multiply here. 360 x equal 16 pi times 60. Divide by 360. And we have x equal, and if you notice this form I have here, it's exactly the form you get if you use the formula I show you on the previous slide. We can simplify here or use a calculator. This 60 goes in 366 times, so we're gonna have x equal 16 pi over 6, which can be simplified by 2, and that will be 8 over 3 pi. So the length of arc AB is 8 over 3 pi. By the way, this 60 degree can be also a special way to do it. You can simply do the circumference 16 pi divided by 6, because we have 6 central angle of 60 in that circle. That is the shortest way, and you end up with 8 over 3 pi. However, I show you the proportion just for you to see it. And the second one, on the other hand, you want to use proportion, okay? And I'm going to write it in a different way. So again, I need to find the length of arc AB, this arc. Again, I'm going to call it x over 110. So you see, I switch the way I'm writing the proportion. I go, hey, the length of the arc over the corresponding angle equals the circumference, which is 16 pi, right? We see the same radius of 8, so that will be good also here, over 360. So it's another way to write the proportion, but you will see the answer should be, the math is the same. So we have here 360x equals 16 pi times 110. I'm going to divide by 360. And that is x, 16 pi times 110 over 360. Again, depends on how you work this problem. You can simplify, or you can use a calculator. Also, so you see I simplify the 0. 36 is an even number, and I can divide by 2, or even by 4, so that will be 9 here, and 16 divided by 4, it's 4. I think that's it, and that will be what, 44 pi over 9. The length of arc AB in this case is 44 pi over 9. Okay, and that's it for this example. Next example, very similar. We need to find different things here. Find the length of each arc. We need to find the length of arc MN if the radius is 10 centimeters. So let's take a look. MN. MN is this arc here. And we notice the central angle is 60, so we can use a shortcut, right? So my first thing will be to find the circumference, which is 2 pi r. In this case, it's going to be 2 pi times 10. So that will be 20 pi. Okay. So we know the circumference, and now we need to find the measure of this arc. So just simply divide by 6, like I said in the other problem. 20 pi divide by 6. Why? There are 6 central angle of 60 inside of this circle. So this one can be simplified by 2, and we have 10 pi over 3. The length of arc MN is 10 over 3 pi. Of course, oh, it says to round your answer to the nearest 100. So let me do one more step then. This is the exact value, by the way, so we need a calculator now. We have 10 times pi divided by 3, and I end up with, rounded to the nearest 110.47 centimeter. Okay, let's go to part B now. And on part B, we need to find the length of arc ML. Okay, but now be careful, MR, which now is the diameter, by the way, is 16. So first of all, if MR is 16, the radius of the circle will be changed. We're not gonna be 10, by the way, like this. Be careful, it's a different type of problem using the same picture. It's gonna be 16 divided by 2 will be 8. Okay, so this problem is exactly what we did in the previous problem. You see, the radius is 8, the central angle is 110. So I'm gonna just copy the answer from there. The length of arc ML will be 44 pi over 9. So no reason to do it again, it's the same math. Oh, let's approximate now. Let's at least do that. And I'm gonna grab a calculator for that reason. So we have 44 times pi divided by 9, and that will be 15.36 if you round it to the nearest 100th of a foot. Okay, and let's move to the last part, where we have to find the measure of arc VR, this gentleman here. And for that reason, we need to find first the central angle, this angle here. And if we take a look, this angle is 60, this is 40, the diameter it's this one, so 60 plus 40 is 100, and 180 minus 100, this should be 80 degrees. So let me be sure I put some math down here. The measure of angle MTN plus the measure of angle NTV plus the measure of angle VTR equals 180 degrees, and the measure of angle MTN, that is 60, the measure of angle NTV, that is 40, the measure of angle VTR is the one we want to find out, and this equals 180. So we have here 100 plus the measure of angle VTR is 180. So yeah, the measure of angle VTR will be 80 degree, like I said here. So now we know the radius is 5. So first of all, we're going to find the circumference to pi r, like we did it before, to pi times 5, and that'll be 10 pi. This is the circumference of this circle. And now we can find the length of the arc VR. I'm going to write proportion x over 80 equals 10 pi over 360. This is one way to write the proportion. So we have 360 times x equals 800 pi. I multiply already the two guys here. Divide by 360. So x will be, I can really do this simplification here, 80 over 36 pi. That will be a good answer, and since we need to just evaluate, let me leave it like that and just grab a calculator and do the math. Length of arc VR will be 80 times pi divided by 36, and I have 6.98. And we have inches here. Okay, in this answer, by the way, can be simplified in case you need it, and that will be divided by 4, that will be 20 over 9 pi also. And that is this example where we have different radius from different problem. In the next thing we move to what we call radian. Radian is a different way to measure angles. Yes, we have degrees, but also we have radians. And the idea comes from this thing. You see, this is the radius of this circle. This arc here, the red one, which I went over, has the same length as the radius. So that is 1 radian. So obviously the second arc has a arc length of 2 radii, the third one 3 radii, and so on. So if you take a look on the last picture here, we have 6 radian, which means this arc here we can use 6 radii to cover. There is a small part left. The question is how much that is. That goes from C equals 2 pi r. You see, this 2 pi, 2 times 3.14, that will be 6.28 r. So that tells you, this small part here should be another 0.28 over radius. And that is the idea of radians, in case you need that. But most of the time in this math level, you're gonna need to know how to go from one form to another form. And you see here, 1 radian is 180 over pi. That's the way to calculate the measure of an angle like this, which is around 57.3 degrees. Okay, for converting, on the other hand, we use these two forms, degree to radians. I'm writing proportion. Radian to degree is the same form, but you'll see how we can handle this type of problem. Down here on the bottom, I said there is an easier way for converting radian to degree. Use pi as 180 and move from there. You will see how we'll do that in my next example. So, for example, convert the following degree measure into radian measure. You should remember that 180 degree means pi. An easy one, right? Here, how can we go from here to radian? Look at here. 30 degree means x. 180 degree means pi. That's one way to do it. Cross multiplication here, so we have 180 x equal 30 pi divided by 180, and we have x equals 30 over 180 pi, and this 30 over 180 is 1 over 6, so it's pi over 6. This is the long way where I use the proportion. After a while you will see it, hey, 30 degree means 180 divided by 6, so it will be pi over 6. That's a fast way. So for example here, 180 divided by what is 45. That will be 4, so this should be pi over 4. Right, the answer. But again, we can write proportion. I'm gonna show you one more time. 45 over x equals 180 over pi, so we have 180x equals 45 pi divided by 180. So x will be 45 over 180 is 1 over 4. So you can see also the math, but again, if you can see the shortcut, why not? And that is about going from degree to radians. I think going from radians to degree, it's even easier, because remember, pi is 180 degree when we talk about radians. Of course, don't forget the pi is also 3.14. So here we're gonna replace pi with 180. 180 divided by 4, that will be 45 degrees. What about this one? This will be 5 times, so that's the first one, let me be sure. 5 times 180 divided by 6. And here it makes sense to simplify. 6 goes in 180 30 times, I'm sorry. So the answer will be 150 degrees. The last one, very similar. We have 4 times 180 divided by 3. Can we simplify here? The answer is yes. 3 goes in 180 60 times. So we have here 4 pi over 3 is the same thing with 4 times 60, 240 degrees. So, like I said, in my opinion, going from radian to degree, it's easier. You don't really have to do proportion. You just replace pi with 180. And the last problem in this lesson is using what is called the this formula, which connects the length of an arc, or arc length, S is called now, with the radius and the angles. But be careful, the angles needs to be in radians. Other than that, we have a problem. So find the length of an arc of a circle with the diameter of 18 centimeter and the center arc of 2 pi over 9. So S equals R times, and this fancy letter, it's the Greek letter theta. Okay, so we have here, we need the radius. The radius will be half of the diameter. So in this case, it's going to be this 18 minus 2. That would be 9 centimeter in case you need the unit. The central angle it's given to us is 2 pi over 9 right here. So it's just about plugging in the formula. The radius is 9. Theta is 2 pi over 9. In order to evaluate, to finish the problem, you can really simplify here these two 9s. So S will be 2 pi. The length of the arc, or the arc length of a circle with the diameter of 18 and the central angle of 2 pi over 9 is 2 pi. And this formula is very useful in case you remember and in case you have the angles in radian, very important. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.